All right, so the first one, 50. What can you go into 50? Tony, you got an answer for me, don't you?
45.
And 2, yes. All right, so we take that, break it down to 2 and 25. Hey, now thinking forward, see how it's numbers on the side board there? 4, 9, 16, 25, 36, 49, 64, 81, and 100.
Yes.
Anybody know what those are?
No, those
It could be.
Those
but-
are all numbers that two numbers can go into, so it's,
Correct.
what's it called?
Perfect square. Those are perfect squares. Now, as we do some of these, okay, eventually, I'm not gonna do it like in the whole class, but if you wanna ask me about it, I'll show you. You can shorten some of your steps. If you would look to see if one of those will go into a number by doing this, like in this case right here. 25 went into it, didn't it? Okay? That's kind of special because now, we can break that down into a 5 and 5, right? But basically, what is the square root of 25? 5. And you can save yourself some steps, okay? So in this one, you should have got 5 square root of 2. But basically, any number a perfect square will go into, you can save some steps by using that, okay? And we can do that some more later, but on this one here, or on the practice ones like that, does anybody have a question? Everybody think you're okay on those? So that's what we did with the video lesson. So make sure today you do some of those. If you get stuck on them, ask, because they're gonna keep showing up. Now, these other warm-up problems are kind of a prelim into what we're doing today. Okay, this one, what's this called right now when we combine things that are alike?
Like terms.
Combining like terms. All right, so in this case, you guys agree the y and the y are the same? So 6 and 1, remember there's always a number there even though it's not showing up. 6 and 1 would make 7. The x's are the same. -4 and 2 would make -2. So that would simplify into 7y minus 2x. So we were combining like terms. And when you are combining like terms, there has to be a plus or a minus in between. So when you get to the next one, this is not a plus or minus, is it? This is a multiply. So when we're multiplying, we can just multiply them together. The 10 and the 8 would make 80. Those two I can't multiply like get an answer, I just have to write down x, y, which is saying I'm doing x times y. Okay, so let's pause for a second. Does everybody see why that's 80 xy? We've done that in the past, but if we need a little review, let me know. Okay, on this one, that does not have a z, so it's not like those, right? These two do have z's. So -7 and 5 would be -2. And we have 8 minus 2z. Everybody good on that one? Who can tell me what this is called? If I take the 4 and I multiply that in there, that's called the what property? Distributive property. So I'm going to take the 4 and distribute it to both of these. I get that. 4 times 6 and 4 times 3. Okay? And I think to the left up there somewhere, you can do this. Write down that problem. Just wondering what it's saying. That's 3 box times 2 star plus 2 box plus 3 star minus box. And then once you write that down, underneath it, write down what you think that would be simplified. Okay? Now try something. Some of you wrote it down and didn't do anything. Write down what you think you can put as a simplified form of that. Michaela. Michaela, you got any ideas? What's that? Ooh, good question. I have two. I had Michaela Hensey, actually. That's you? All right.
4 box plus 5
Say it again, I'm sorry.
4 box
Ye-
plus 5
Nice. You ever hear what she said? 4 box plus 5 star. What you did was what I wanted you to do, saw that it doesn't have to be an X and a Y to be like terms. It could be anything. Like in this case right here, do you guys agree these are all the same?
Yes.
Okay? So I can add the coefficients. I got a 3, a 2, and a -1. That make sense? So to add those up, what was that we got? I'm sorry, 4, right? Plus the stars, I can add them. And I get that, right? Does that make sense, everybody? Because we're gonna use that idea with what we're gonna do next. Okay? Go down to number 3. The next one down there. Okay, do you guys agree on number 3? We have 6 square root of 3 minus 4 square root of 7 plus 2 square root of 7 plus square root of 3. So if we have that, do we have like terms? Now we see numbers this time, but now what I want you to think about is, remember over here I have the stars and the boxes? Okay? Think about these square roots being in their place. Is this square root and this square root the same? You guys with me so far? Now, what number is really in front of that? A 1. There's really a 1 there. So if we were counting square roots, this is really saying I have 6 square roots of 3 here. I have 1 square root of 3 there. So I have 7 square roots of 3. Okay, so let's pause for a second. Think about that. So the like term here is the square root of 3. The square root of 7 and the square root of 7, they're both the same, aren't they? So think of this in terms of if I had a minus 4 square root of 7, it's like I'm taking away 4, right? And then I added 2 more in, that's still like saying I'm taking it away, or -2 square root of 7. Is everybody with me on that so far? So basically what we're learning today is radicals, which is a fancy name for square roots, can be like terms. They just have to be the same exact square root. Now you guys try number 4 real fast. Write down what you think that one would be. Alright, so what's our like terms here? Those 2 right there. This does not have a square root with it, so is it a like term? It's by itself. It's just like the 8 right there. Okay, basically, that problem right there is the exact same as that one, isn't it? The only difference is the z is the square root of 2. So if we combine these 2, do you guys agree I'd have 8 minus 2 square root of 2? So you combine like terms there. But now this one, okay? Look back to the problems we did up here. Is it really the same as that problem right there? You guys see how they're similar? Okay? Because what's different about this one is they put parentheses around it, right? That's just telling you I'm multiplying those things together. So what would I do with the 10 and the 8? We'd multiply. I'd have 80. then I would multiply the square roots together also, right? Now, the one thing that is different here though is, can I multiply square root of 2 times square root of 3? This is what we learned 2 days ago, I guess. Okay, we can multiply them together, can't we? What is square root of 2 times square root of 3? Square root of 6. So I have 80 square root of 6 for that one. Anybody think of a question real fast? Because we're gonna take this and I'm gonna show you why we're doing this, okay? Because what we're gonna do today is take shapes and we're gonna find the area and the perimeter. Now, before we even work this one out, let me ask you a question. For perimeter, are we adding or are we multiplying? We're adding, right? So when we're adding, it is like this right here. You guys with me? Combining like terms. When we are doing area, we are multiplying, right? So when we multiply, it's like this right here. So if we were gonna find the perimeter of this one, they say perimeter first. Yeah. Okay, now remember, we're gonna have 4 sides, right? So here's what I'm gonna write down first. I would take 4 square root of 2 plus 7. Do you guys agree I'd have another 4 square root of 2? Okay? And then we would have another 7. Does that make sense, right? So that's basically what we're starting with. That's our 4 sides. Now we just have to think which sides are alike. What parts can I add together? Can I add the 7s together? These are alike, aren't they? I got 14. And then these are alike, aren't they? So I have 8. I forgot what unit I had on there. Centimeters. And it's not square, because remember, perimeter, it's just whatever it is, centimeters, feet, no square, because it's not area. Let me pause for a second. You guys with me on that one? And then if we're gonna do area, we're gonna take the 4 square root of 2 and multiply it times 7. So the 7, is it gonna get multiplied by the square root of 2? You can't put them together, can you? You guys with me? But can I do 7 times 4? Yes. So I get 28 square root of 2 centimeters squared.
Those are
Is everybody with me? I do want to ask one question before we go to the next one. Because sometimes this can be confusing. You got these parentheses, right? Why was this not a distributed property? Yeah, well, we got the 7 here though, right? You with me? Even if it was there, it's like, so the 7's on the outside. Why did I not do 7 times both parts? Say it one more time. That's not why this time. Even if I would've had it like this, it still wouldn't be distributed. Yeah, well, there's even the square root though could. I'll show you exactly like, here, let me write it like this. Did you say something? No, somebody over there? I can't tell who's talking fast sometimes. I could have swore somebody had an idea. Never mind. All right. If it was like this, is that different than that? It's close. What's different? Yeah, I put a plus sign in there, didn't I? You guys see what I mean by that? Does that one have a plus sign? Yeah, you did. Does that one have a plus sign? No. So what do we have to have? Thank you. What do we have to have to do distributed property?
A plus or minus sign.
Plus or minus. Like that could have been a minus in the same. You guys see what I mean by that? They were just multiplied together, weren't they? That's why that is not distributed. Because sometimes they can trick you and it looks like it, doesn't it? But what's missing is there's no plus or minus in there, okay? I think they're good on that? Good? Alright, let's go to the next one real quick. Now, on this one, we're gonna cheat a little, cause I just wanna do the concept first, and then we'll come back to this. But if we're gonna do perimeter on this next triangle, what's missing for us to do perimeter?
A right angle.
Like, do we know, well, when I say what's missing, what do we need to figure out? Yes.
The slanted side.
Yeah, now actually, now go back to, that's not the hypotenuse though, right? You guys with me? When I say that, it's not the hypotenuse of the big one. Do you guys agree? We need to know this side and that side. That's what I wanted to get to. That's all I was really asking. Like, you gotta figure out those two sides. And we would have to do Pythagorean theorem. Okay, I'm gonna tell you what they are just right now, because I want us to work out what we just learned there. You guys with me? So that is 10, and that is 3 square root of 5, okay? So I want you guys to now, what would I do to find perimeter? We're still doing this one together, then I'm gonna let you do the next two on the bottom by yourself. What would we do? Add. We would add all three parts together, right? We would add 3, 8, 10, and the 3 square root of 5, wouldn't we? What parts are alike? 3, 8, and 10, aren't they? So we would have 21 plus 3 square root of 5 meters this time for perimeter. Okay, so let me pause, make sure has everybody got perimeter down? Does everybody see why we'd add those parts together? This is the only one that has a square root on it, right? So that's the one I can't combine with the other sides, because they're all alike, I can add them up. Now this next part, make a note of this, or you'll do a lot of extra work sometimes or be confused. On this triangle, if you look at it, and we know that the area of the triangle is 1/2 base times height. When you first look at it, I have 11, that'd be my base, right? Add 3 plus 8. I don't know the height, though, do I? But there's already a base and height up there you can use. So if you know why, or you know what they are, tell me, and how do I know that that's the base and height I can use? Because when we work with right triangles, this is gonna be important because this will make your life easier. Pardon? 8 and 6? Oh, no, hold on, are you figured out the other side? Don't. Let's say we don't know the 6. If you did that, you could use that, okay? Here's what I'm trying to point out. Everybody see the big triangle? See that right angle? Yes? If two things form a right angle and a right triangle, is that the base and height of the right triangle? In other words, if this triangle was written like this, would you use that and that for my base and height? So anytime you have a right angle and you know the two legs, that is your base and height of your triangle. So I could have done 1/2 10 times 3 square root of 5 for the area. Does everybody see why I could use 10 and 3 square root of 5? Anytime there's a right angle, that can be used as the base and height. So basically, once again, I want to make sure we understand this idea. We're multiplying them together, right? What parts can get multiplied together? 1/2, the 10, and 3, right? So 1/2 times 10 is 5, right? 5 times 3 is 15. And that would be our answer.